Okay. We have Donna's here. Who's Donna?
Haven't I changed you to host of the meeting?
I see that. We have some other folks joining us.
Suit here,
early.
Robert Torgerson. All right, welcome. Donna.
Robert's our buddy from WICA on the hot seat. Okay, some questions. Monica, the survey link is still valid. Looks like it is.
It
Unchanged.
should be, yeah.
All right. I'll be hiding in the bottom for later. How's my audio? You guys hear me all right?
Sounds good.
Yes, we are. There's occasionally a click, but not very often.
Turning my cell phone to silent, so I am not one of the bad actors. Mouse. I'm going to share my screen, make sure that's cooperating. That way everyone can see all the chaos that's happening on my side.
See that Axier's joined, and Caitlin, Stephen Orser, or Stefan? Stephen, probably.
Stephen, yeah.
All right, welcome. Where are you from, Stephen?
CNRL.
All right. So you having a spring day, or is it still winter temps up there?
It's still winter
Yeah.
for a few more hours. It's supposed to warm up in the afternoon and
Warm
get
up
above zero.
For 20 minutes.
Yeah, exactly.
My wife did a marathon in Anchorage, Alaska in June. So it was June 23rd, so just about the longest day of the year. Our first
Yeah.
experience of being that far north in the middle of the summer. And 11:30 p.m., it's like middle of the afternoon.
Yeah. Yeah, it's a little bit hard to get to sleep here in the summer too.
Yeah.
I wouldn't know. All the time I spent working up at CNRL, it was pitch in the winter.
Yeah. On the Coker structure.
Oh boy. Oh, that's the hottest place on the unit. That's where everybody hides. Get out from the cold. Stand out by the charge pump for a while.
I see Dennis Sutton has joined the call. Where are you from, Dennis?
I am currently residing in the Denver, Colorado area. I worked most of my career with Marathon Petroleum.
On site or in the resource centers?
Good question. All of the above. I started my career in their research center in the Denver area, worked at 3 of their refineries in Indianapolis, Robinson, Illinois, Texas City, and concluded in their supply group in Findlay, Ohio. And I now head up the Crude Oil Quality Association.
Oh, okay. Excellent. Oh, glad you could join us.
Thank you.
I've gotten some material off the Crude Oil Quality Association website. It's very nice.
Okay. Yeah. Well, we're sort of a niche group. Where are you guys based out of? Houston area or?
All over the place. I'm north of Seattle. The other folks can answer for themselves.
I'm in Boston.
Hi, Dennis. I'm in Denver as well, just south of Denver.
Okay, actually, I'm in Littleton.
We're very close. I'm in Centennial.
Okay, I used to live in Centennial years ago, but
So you just moved a little west, huh?
we did. I worked. Marathon had a research center for many years on South Broadway and Dry Creek, where I worked. Then a number of transfers and retirement from Marathon, and now I'm way west, out towards Southwest Plaza Mall.
That's kind of a nice area, up and coming.
Yeah, interesting.
So can everyone see my screen?
With with PowerPoint slides or slides.
Yeah, you got the big PowerPoint on one side, then you got Slido questions to the left.
Yep, perfect.
Got it, just checking, thank you. You guys are getting to see how the sausage is made. Backdoor activities. All right, Mr. Lemashev, how are you? I see you're on the list. Michael,
Hey guys, what's up?
nice to see you. How you doing, buddy?
Doing all right. All right.
Got
Having a
another
good
Michael
time.
the Michael Kimbrell just joined. Very cool.
I see SMB walking around.
Yes. Yes, I'm ready.
Nara Kilshakuma. How do you say your name?
My name is Nair Akhil Sukumaran. So it's Akhil Nair actually. I am joining you guys from Bharat Petroleum Corporation, Cochin Refinery, where we have got a 3.84 MMTPA DCO.
Awesome.
And
What time is it
over there? Yeah.
Oh, it's 8:30 p.m. Paul, and all excited for this conference. Yes. How are you? How are you? You guys are good?
Yeah, we're really excited too to be kicking this off and got some good information today.
I'll be
That's
better
great.
when I know all the technology is working just fine. But so far, so good.
Huge fan, Ivan.
Oh, thank you. Very kind. All right, so the chat seems to be functioning. That's good. People are trickling in. I'm gonna mute everyone now, and then you will be able to unmute yourself, but just for the sake of audio clarity, I'm gonna put everybody on mute.
Nada, llegaron los abuelos, qué chulo.
There's Javier Varela. You're from Latin America? Good to see you again. Oh, you're on mute. And Ryan's on
Now
the
you
call.
can hear me.
Yes, okay, very good. Nice to check in.
Morning, Paul.
Hi, Ryan.
It's working. So I see that some people are already into Slido, which is awesome. There's some questions popping up over there. I'll do an introduction for everyone else's benefit on how that works in a minute, but I'm glad to see that some people are getting in there. The event code, most of you already seem to have figured out, is RefCom. Whoop. There'll be bonus points at the end of the session for anyone who can identify the coker in my Zoom background.
Ooh, double bonus points if they get mine too.
Uh-oh, somebody at our friends in Axion, Buenos Aires didn't receive the link. So let me get that to them real quick.
You know, we're well represented in Argentina. Irene Mendoza at Pan American. Sorry, I didn't say your first name well. And Carlos was there. So we got Asia, South America, North America. Luis Zabala, Florencia Cherry, B. Robinson, Mike Kimbrell, Marco Simic, Rupan Mukherjee, Donna, Tim Michalowski, must be a relative of me, Paul Orlowski, M. Burchenkov. And I'm sorry that I may not be pronouncing these names right, but I just want to give you some bit of a shout out. Tarek Malik's just coming in. Okay. Aaron Nogan.
Tarek's going to ask all the hard questions. He always does. Oh, man.
Son Yuen, Redme, Carlos Alvarado, Axier, okay. HVS, Me Tenner, that's more of a Russian name. Okay. James Turner, Edward White, HN Varma, Asia Ruiz, Jonathan Garcia, Juan, Sam Morenez, Kieran Proverbs, Juan Kim, Rick Henneford, Mitch Maloney, W597123. Okay. And the names go on and on. P. Terry, Tom Willett, Punit Kumar, Srini Srivatsan, Carlos Emmanuel, Narenda, and Kozlet. Hi, Nikki, Emil, Randy, George. We're starting as soon as you're ready, Evan.
All right. We only have an hour, so we're going to try to keep this tight on time. So welcome, everyone. We're super excited about this. This is our first edition of EU RefCom. And fingers crossed, all the technology is working at this second, which is awesome. I probably should knock down wood for that. So I have some introductory slides. On my screen, you see slides on the right, Slido on the left. I'll explain Slido in a second. By way of legal CYA, this is an open meeting for members of various companies. So typical antitrust disclaimer, we're not going to talk about money. We're not going to talk about suppliers, customers, bids, employee salaries, any of this fun stuff. That's completely off limits. We're here strictly for the goal of sharing mechanical, technical information to improve the safety of delayed coking in general. That's why we're here. So thank you all for joining. Some etiquette reminders. Please keep yourself on mute unless you're speaking. I've muted everyone directly. You do have possibility to unmute yourself. For those of you who are on the phone only, can't see my screen, I apologize. But you can toggle mute, unmute using *6. There are a number of people in the meeting from outside the US, so please speak clearly, speak slowly. Don't want any phones ringing in the background. As always, our mantra is trying to share knowledge and experience, so please be open with your experiences during the discussion section of today's meeting. And lastly, because we do have a lot of people on the call and the virtual meeting today, we will ask that you raise your hand to speak, and I'm kind of monitoring it on my other monitor, and we'll call on people to address questions. So that seems to be working just fine. Again, for those of you on the phone, *9 toggles the speak little virtual hand. So there's a way to do that on the phone as well. So we're using Slido for our Q&A and live polls. You'll see that on the left-hand side of my screen. Many of you who have come to our events before are obviously already familiar with Slido, but because not everyone is, we're going to do a super brief introduction about Slido. Basically, you go to the website, add the event code, which in our case is RefCom, no E. You can do it a variety of ways. Most importantly, we really want to make this a dialogue. So questions are visible here on the left. And please vote on questions that you find are most interesting so that, in the course of the discussion at the top of the session, we want questions to kind of bubble up that most people are interested in. So use that little thumbs up button.
Hello, are you hear me?
Yes, I can.
Can you hear me?
Yes.
Yeah, Piyush Divakar from India.
Hello. Thank you, Pushyas. I'm going to put you on mute right now. All right, very good. Okay. So we're going to be having live polls as well. No polls are active at this second, but you'll see it on the screen or you'll see it on your phone. How to jump into the live polls. So it's pretty straightforward. Everyone who's used it seems to pick it up very quickly. You can go to the website manually. You can use your phone for this cool QR code to jump into the Slido. So again, encourage everyone to get in there. So the topic for today, sort of the agenda, is we're going to do a very short intro. I'm almost done. We're going to do 10 to 20 minutes of content that I'm going to deliver, and the topics there on the right. For those of you who are familiar with our live events, we try to use these breakout style sessions as ways to answer questions and share knowledge, not just from me, but from everyone. So we want to try to smush the content into as short a period of time up front, leave maximum time for question and answer periods from all of our collective wisdom here, and then we're going to have a bit of a wrap up at the end. So big thanks to our friends at Daily Thermetrics and WICA that helped me source some of this material for today. This has been a team effort getting this off the ground. So I really want to thank those guys for their contributions. And they may have some opportunity to chime in here later about some of the stuff that they shared. Okay, so let's jump over to the presentation material. We were going to focus on 3 topics today: coil outlet temperature, skin TIs, tube metal temperatures, and fouling. However, the material that I have all of a sudden just exploded in the last 3 days, and I feel like I don't have enough time to do all 3 of these subjects justice. So I'm going to skip directly to the skin temperature discussion because I feel like it's more meaty, and it's something that we all struggle with as an industry. So we're going to come back to the coil outlet in another episode of eRefCom. So we're just going to table that for now. But if you do have specific questions about the COT later in the Q&A, feel free to bring them up. But I'm just going to dive right into the TMT discussion for the sake of brevity today. So let's jump through this. All this fun stuff we're not talking about. Okay, so to the TMT. So now we're going to do our first poll. And this should jump over the screen on the left. How many skin temperatures do you have per pass? Less than 5, 5 to 10, etc. So if you're in the Slido, this poll is going to stay live for a few minutes. I see people already jumping in there and voting. That's awesome. So we're going to move forward while the poll is active, and we'll come back to that. So there are a variety of different styles of skin thermocouples out there in the world. The most simple one is where the thermocouple is welded directly onto the tube, this weld pad. A slightly better style, more accurate style is this V-pad style. And then this is often referred to as a knife edge style. V-pad's WICA's trade name, generically as a knife edge. And this particular one is unshielded. Now there are a variety of different designs which are shielded here. So you see this big piece of metal, and there's 2 different styles, refracto, extracto pads. here. And inside of this is either the weld pad or the V pad, and it's shielded from the temperature. And the reasons why we'll discuss in a few minutes. Also from our friends at Daily, they have similar designs. You know, I won't say they're the same, they're dissimilar, but you can see from their literature the various different styles. And in particular, you know, the one that we see most commonly in the delayed coking industry is this knife edge, again, with a heat shield over the top. So nice diagram showing how the whole system is meant to work. Basically, you have a penetration in the side of the furnace, some sort of coil that takes up some thermal expansion, and a variety of, and this wire is called the mineral insulated cable, MI cable, and it's clipped to the tube in various ways, and we're going to spend a lot of time actually talking about the clips and the cable runs, because this is one of the biggest issues we struggle with in our application. And then at the end of the run, you have the knife edge device welded to the tube, and then you have your optional heat shield over the top. A couple examples. So this is a heat shield here on the left. On the right, you see a weld pad. Not exactly sure what the operator was going for in this example with this giant layer around it. But another example is from a different vendor. Again, a sort of heat shielded design instead of the curved one. This is more of a straight linear version, still with the heat shield. So a few comments from a high level perspective. Basically, you know, as we all know, this measurement is super critical to our applications. But one of the most important things to remember is that unlike a lot of other process heaters, these things move in our example. And in particular, during online spalling, things tend to move around, shake, thermally expand, contract. And this is one of the challenges for keeping the system reliable over the long term. We're going to talk a lot about the cable routing in a few minutes, but you'll notice that these cables are just sort of free floating in space, and that becomes a liability in terms of the reliability of the installation. And the guys at Wyca are noting that if you do it wrong, you can have 1/3 the life expectancy. So, you know, how you install these things is super important. And because, I'm going to say this now and I'm going to say it at the end, because this measurement is so important for us to get right and to be accurate and to be reliable. You know, in my opinion, no amount of money is too great. I mean, obviously there's limits to that, but you got to have the experts putting these things on and installing them, because, you know, that cascades into coil out temperature, cascades into yield, it cascades into, you know, how much downtime we have on an annualized basis. There's so many things financially that are tied to this. Then if we turn it around to the safety aspects, if the tubes get too hot and you don't have them reading the appropriate way, you know, obviously you can have tube failures, fires, etc. One of the things I wanted to touch on is I showed earlier that there are this type that has removable type Thermowells. And generally speaking, those can work well in some applications. However, my personal preference and the consensus of the vendors I spoke to earlier this week is that we don't like this in the delayed coking application because of the movement that occurs on the coker heater. You'll notice some pictures I have here. This little notch is a little indentation that's meant to secure the thermocouple in the very bottom of this pass. And I mean, you can imagine that, you know, all the shaking and rattling around that we do on our furnaces, this little notch is not going to hold this thing into place. There was one anecdotal story that I was they shared with me. where one of these things kind of slipped back from its base, and it was reporting 40 degrees hotter than actual reading. And you can do the math for your site as to how much shortened runs you would have over a long period of time and how much financially detrimental that can be, but it's very significant. So let's talk about the argument of shielded versus unshielded. By and large, most operators in industry have quiesced around the shielded design. There's one notable standout. I'll leave them unsaid, but most of folks that are in the business know. But generally, unshielded are good because they're faster. They read a little bit hotter, but there's this discussion about what's right. The right number is what really we're trying to get to the core of, and that's debated, and we're going to have some discussions about infrared in a minute. But they're easier to install, they're cheaper, but if you're doing online spalling, in my opinion, they can break a little bit easier because you have less weld holding them onto the tube. Obviously, the shielded, is harder to install, more expensive, but it's more robust of an installation, but it can also read a little bit colder, and that may not be true and accurate. Therefore, you could actually be running your tubes hotter and deeper into the creep regime than you may like. So there's sort of the pros and cons. Like I said, most people are using shielded these days, but there's some interesting research going on that WICA is doing that they're hoping to share with us in the next maybe 6 months. We're a bit premature, but they got a little R&D furnace that they're running, and they're going to give us some good results from a real furnace side by side. So stay tuned for that. So where do we install the TMTs? I'm not going to read this all to you just for the sake of time, but you can see there's some specific spots where you want to put them. Some additional considerations for flue gas, where you might want to distribute them all over your furnace. And lastly, let's not forget to put them in the convection section. I know everyone's so concerned with just lower radiant fouling, but we do have fouling elsewhere in the furnace. So let's jump back to Slido. See, we have 27 results. That's pretty cool. Most people are in the 5 to 10. Not many people have less than 5. That's good. There are a number of operators that are pushing 15 plus. So this is consistent with my experience in the industry. Newer units are getting more and more and more. Still, there are units that tend to have fewer. And obviously, the more the merrier, because we're aware of what's happening on our tubes more all over the furnace. So let's discuss that for a second. So sort of in the old design, you would just sort of see your skin temperatures in a vertical line. Then some smart people said, okay, well, let's add a few more. Almost all of our foulings in the lower radiant, you would put them down low to kind of catch what's really happening at the outlet of the furnace. This can be useful because it's 2 measurements on the same tube, good for comparison. But again, you're sort of not getting that bifurcation of information. So then people came along, started putting more on there, and again, kind of concentrating on the lower radiant section. And we still see this today in some installations where most of the TIs are concentrated in the bottom. And again, this is where historically you would expect to see all the fouling, but we're forgetting about all this area up higher in the furnace. So one of our recommendations is, don't forget the full radiant, especially if you're dealing with weird feedstocks, contaminants in your feed. You can get upper radiant and even convection section fouling, and having skin temperatures up high, there's really no substitute for it. Infrared is challenging up high in the radiant box just so accessibility. So the more the better, but also try to have good coverage all over the furnace, and then also don't have them all in a vertical line. That you're only going to see what's happening in front of that one burner. try to bias them one way or the other. So next we're going to move on to discussion about the MI cables. That's a problematic for us. I'll show lots of examples of how those fail. But one of the key aspects of keeping these things reliable is they must be kept cool. And so how do we do that? We route the cable on the quote unquote cool side of the tube. And that varies depending on whether or not you're single fired or double fired. But also if that little MI cable is gapped off the tube, even just a little bit, 1/4 of an inch, 2 millimeters, air is a good insulator. You're not going to get that thermal cooling effect. So it's got to be nicely touching the tube. So when you go in your furnace and you look around, pay attention to that. There's some bending radius specifications there. You don't want the installer to over crimp it or else it's going to break. And then there's a variety of different materials that you can actually make your sheath out of. 310 stainless is kind of the base. But now we're going to jump to the next poll. So what is the material of your skin temperature measurements? 310, Inconel, Hastelloy. Have you considered upgrading this? And lastly, I have no idea. So we're going to let that poll run in the side there for a minute and talk about how routing these things is so mission critical. You have the little clips. They need to be installed every 8 to 10 inches. They need to be tight, but not too tight because, again, these things expand thermally. And if you really mash them down on the tube, you're going to get the spaghetti effect on the cables, which I'm going to show you in a minute. Another little subtlety here. When you're routing it through the wall, it's a good idea to sort of minimize that bend in there so that, again, it doesn't put extra stress on the cable, which leads to premature failures. This image, a little side note, is from YouTube. Waika has a pretty cool YouTube video channel, and they have installations of both the V-pad and the refracto pad style animations on the internet. I would encourage you to check those out. So let's talk about where in the firebox we put these penetrations. Old single-fired design furnaces, no problem punching it through the wall of the furnace. Obviously, you have a penetration in the refractory that you have to deal with, but that can work very effectively from the health standpoint of the skin thermocouples. On the double fired, however, if you punch through the side, you have to traverse the flame path. And obviously that's very aggressive temperature for the skin temperature cable to withstand. So this is definitely not recommended. A couple examples for you. You see that this cable runs fairly unsupported, not really shielded from the flames in any way. You have a single clip, a couple, thermal expansion bends on here, really not the ideal installation. Another example of, a subpar installation, one of the things you'll notice is that this thermocouple is relatively close to the hanger. Not only do you have to have distance from any old thermocouples to prevent some, some thermal effects from the old to the new, we say minimum 6 inches there. Want to be like 12 to 18 inches away from hangers because, again, you get some pretty aggressive heat transfer from there into the thermocouple. So not the greatest spot to put that one in. Here we're showing, just a single expansion coming through on the tube. This is a touch point that can get aggressively hot. This is on the flame side. Again, you got to keep this sheath cool or else it's going to fail. So some problems with that installation. So let's look back at the poll. We have majority of people using 310. A bunch of people don't know. I have a feeling after this virtual meeting, you're going to go to your instrumentation people and ask them what you have. I hope so. So you come away more educated. Some people are using the higher metallurgy. That's great. Should up the reliability. Pretty cool. So let's switch to our next poll. So we're looking for information about frequency of failures. So during your average pigging, how many of these things do you replace? So we're gonna let that run. Moving on. So you can also see installations where the cable punches up from the bottom. This is okay on a single fired design, but not really the best option because again, you have long runs of cable that can be unsupported. And the same comment is true for the double fired. Not the best, we'll talk about the best in a minute, but it can be effective if done properly. So some examples of that, you see, the cables running down, fairly unsupported. They're also not being cooled in any way. So that can be a problem for the ultimate reliability of the skin temperatures. If you have a double fired furnace, the recommended method is actually to put it in the end wall so that the cable runs across the top of the tube, stays relatively cool, and stays supported along its entire run. A couple examples of that. Here we see, some clips putting too much force on the cable, not allowing it to expand and contract well. You get some sort of spaghettyification. Similarly, another example of a spaghetti movement on the skin temperature. And that, again, this all just leads to premature failure. More examples, clips, not quite holding the cable run. It's sort of biasing itself over onto the hot side and getting hotter than it would be otherwise, sagging from the floor mount installation. Here's a nice example of taking into consideration the fact that the ladder supports for the tubes can actually become a pinch point for this cable. So rather than running it directly along the top, they actually deviate it just a little bit, like from the 12 o'clock to the 2 o'clock position, so that as everything grows and moves around, you're not going to be pinching that cable during the operation. Again, staying with the concept, things in our feeders tend to shake around more than your average furnace. So let's make sure we install and design these with this in mind. A few more examples of problematic installations. Cables free floating in the air, not going to help you from a cooling standpoint. Similarly, the expansion loops, not ideal. These guys, obviously that cable has failed. So if your skin temperature does blink out, you maybe could open one of the PEEP doors and see what's happening there. Sometimes the cables do just break if they get overheated. Another little subtlety about installations, how you actually penetrate through the firebox is important. This particular example is of a piston style. So it allows for that thermal expansion to take place outside the firebox. And so you just use a spring to kind of keep tension on it. And that can work very effectively. There's some subtlety in the design about how you actually keep, from flue gas escaping there or air ingress. So, check your installation manual for those details. So these things will die most of the time. People will just clip the cables and install a new one. Again, you want to make sure it's 6 inches from the last one. Don't forget to change your skin temperature map of where your skin temperatures are physically located if it's changed subtly. My last point here, we do a lot of consulting directly to refineries all over the world, and you'd be surprised how many plants I go to and I ask the process engineer, please give me a map of your skin temperatures so that we can compare, what TI 2703 is doing, and they kind of look at me with a blank stare. So hopefully all of you have a map showing precisely where all these TIs are on the coils, and you should have that handy, especially with your heater monitoring. As you're doing your daily, weekly, monthly heater monitoring, you should be referencing that so that you know, oh, the one in the middle of the firebox just got hotter. Something must have changed. So getting back to the removal, most people leave them behind. Some people do actually grind them off because there is some heat transfer effects locally with that extra chunk of metal. But if you do that, you risk getting into the base metal. So pros and cons. All right, so back to the poll. Many of you say greater than 5 are replaced during the shutdown. That's interesting. So you're having a lot of failures on the run. Interesting. I hope after this discussion, you can go and take a harder look at how yours are installed and what you might be able to do to make them more reliable. So the last point of this discussion is we're going to do a super brief discussion about fouling. And we're going to move to our last poll, which is what is your fouling rate? Various fouling rates in the furnace. We could probably do an entire one of these discussions strictly about fouling. And I'm just going to try to hit some of the high points here today to leave room for discussion. So here's a nice trend of 3 years worth of data. There's lots of aspects in my longer form training that we go into that we could dive into what this is telling us, but let me just kind of hit some of the high points for you. Here we're seeing some laddering effects from online spalling not being completely effective, and then you shut down for a pigging. You can tell that because the furnace got cold versus not getting cold, and you come back to that proper start of run. Here we have some upset conditions, and then they shut down for a slightly longer pigging. You'll notice that the blue and the teal line historically are fairly low. During a particular run, they were getting some aggressive temperature increase there. That's sort of a red flag. What changed in our feed or our operation to have that result? And then it kind of went back to the historic normal. And then sort of in the more recent times, normally for 3 years, the red line, whatever TI that was governing. But all of a sudden the blue is now greater than the red. So you start asking yourself, well, what's changed in my flame patterns? What's changed in my feed to result in this style of change? So like I said, monitoring skin temperatures is something that we as the process engineering people do, hopefully daily, weekly, monthly. Here's some examples of things that not just a straight up trend. I think you should do delta T's, time fouling rates over time, slopes, use some extrapolation. You should monitor the total amount of volume of oil throughput on a given run, and compare that run versus run to see if you can optimize that. And then lastly, I've seen some smart people basically, take the start of run as day 0 and, extrapolate out, or not extrapolate, plot out, 100 days on oil, 30 days on oil, and overlay all previous runs onto one graph. And I find it to be very, very effective from a visual standpoint, seeing how this run compares to other. So that's a pretty cool, simple Excel exercise. We also want, operators to check the furnace every shift. We recommend that people use infrared guns on a weekly basis. And then infrared imagery is also very useful for hotspot determination. I'm not a big fan of using infrared for absolute measurements, temperature measurements. We probably should have a special EREFCOM only on infrared monitoring because it's a really interesting topic. But let's just dive into it from a very high level. So here we have a IR double-fired furnace. One of the things that grabbed me about this one, which is why I included it, is you see hot tube, cold, cold, hot, hot, hot. So if you have your TI mounted here, you have one opinion about how your furnace is running. If you have your TI mounted here, you have a different opinion about how your furnace is running. that hence more TIs are better, but there's no substitute for infrared for looking for hotspots and maldistribution of temperature. There's a lot of discussion we can have into this bar right here, but I will table that for another day. Emissivity, the ambient temperature in the firebox is not 20 degrees Celsius. So lots of interesting caveats in this image as well. Another little couple examples for you. I call this one my zebra stripes. This is where, you know, after an online spall, you don't necessarily get everything perfectly clean and you get some coke left behind. And so again, you know, whether or not you have your TI here or there, you have a very different conclusion as to how your furnace is running. Similarly, you, at the top of the firebox, you can get, you know, very strange distribution of fouling, even on the shield tubes. So this is something, again, to pay attention to. So in my experience, a lot of the fouling that occurs in our furnace is a result of the feed quality, and that's a very long discussion. Here we have just listed some of the components of feed quality that govern the fouling rates. So, you know, high concarbons, high asphaltenes, you know, the aromatic nature of your feed, aka UOP K factor, inorganics, in particular sodium and silica for our friends up in Canada are very, very bad actors for heater fouling. Other solids can give us trouble as well. So lastly in this section, you know, some of the things, if you do see a spike up in skin temperature, this is a bit of a checklist. You know, is my skin temperature lying to me? Do I have some localized burner impingement? Is the flow telling me the truth, et cetera, et cetera? Something changed in the flue gas side, oxygen characteristic change, has the bridge wall temperature change? All these types of things are things to sort of tick off your troubleshooting list. But this is a comment from my friends in operations. I'm talking to you. I know that sometimes when skin temperatures go up, there's a tendency to walk out in the field and kind of pinch that burner back directly in front of that TI. And that's a bit of a no-no because you're just, you know, covering up the problem. Unless, of course, you can confirm that it is in fact a localized burner problem. So don't just pinch the burner to make management feel better about the situation. Okay, so fouling results, we got 26 results, not bad. Seems like the same 26 or 27 people are voting each time. Most people are fairly low, that's good. You got a couple people in the pretty aggressive fouling regime. Some people that are doing excellent, less than a degree per day, good on you. But this is probably normal. 1 to 3 degrees is, I would say, industry norm. So if you're better, great, etc. So that's pretty cool, right in line with what I would have expected. So just by way of recap, the skin temperature is one of the most important measurements in the unit for all the reasons stated. So make sure that it's installed correctly. Generally, start of run is on the order of 1,000 Fahrenheit. End of run is 1,300 for 9 chrome. There are other metallurgies out there. You have 347 stainless, you have Inconel 800 HT. So there's 316, 317 stainless also. So you get other metallurgies out there, but by and large, most of our furnaces in the world are 9 chrome. So we're right sort of in the normal range there. And yeah, they can fail. Show lots of examples of that. So that brings me to the end of the presentation material. That took me about 5 minutes longer than I wanted. So let's go to questions from Slido. We got some good votes. What is the life expectancy of the thermocouple? I actually don't have a solid answer to this. Maybe I would encourage our friends from Daily or Wyka to answer this directly. Aaron or Robert, you got a comment?
So this is Robert. It's tough to answer that because of the variability of materials and conditions and where that is, and then the quality of the installation. So a lot of factors go into this. On the downside, we see some of these only lasting 6 months. With a quality installation, you get some of these that go more than a decade. So the range is really wide. Pick good materials, do good engineering, and get a good installation is what you need to do to maximize this.
Aaron, anything to add to that?
No, on our side, I think we would echo just about everything Robert suggested. Carlos Alvarado, feel free to jump in if you have any specific comments yourself.
Okay, I see that Paul has his hand up. Paul, do you have a question?
Oh, thanks, Evan. I was just going to cue you a couple minutes ago that we needed to get into the questions. You're doing great.
Thank you. We're talking.
Can you hear me now? This is Carlos, sorry.
Yeah, go ahead, Carlos.
Okay. As I said, we'd echo those same sentiments. There's a wide range of issues that can cause the life to be short or be fairly long. In general, what we see kind of as a rule of thumb for severe heaters like Coker services, we say anywhere in a range about 4 to 6 years is considered good life. And realistically, after that mark, those probes have been cycled so many times that you need to probably look into getting replacements so you don't have any failures on the next start of your run. So if you were to follow some of the API recommendations, they suggest you replace TMTs at every available shutdown that has sufficient time to do so. But rough rule of thumb that we're kind of seeing is in the 4 to 6 year range. You can kind of consider that a good run life. As the gentleman from Mike said, anything under a year is definitely suspect. You have some scenarios where they do fail that soon due to some manufacturing defect. But if you're getting majority failure under a year, you need to look into your metallurgies and your routings and see if there's any improvements that can be made.
Cool. Thanks, gentlemen. So moving on to the next question, how do you tell if your coil outlet temperature is accurate? Oh, we didn't cover the COT, but we'll address this. My comment on that would be you have to look at where it is over time. I don't know that there's any way to determine it from an absolute basis. You can compare it to the individual passes, to the combined, to the drum inlet for some sort of sanity reality check. But I've tried, IR on the outlet elbows. I've tried, little magnetic stick-on jobbies. You get sort of artificially cold information. So that's my perspective. Does anyone else from the audience have a perspective?
Evan.
Yes.
Yeah, Maximiliano here. Is it a common practice to install a double thermowell outside the furnace spaces?
Yeah, hi Max. Good question. I'd say in the newer furnaces, it is. Oftentimes there's, one's on control and one's on trip for an interlock perspective. I'd say that's only probably been in the last decade that you start seeing furnaces with multiple COTs per pass. But on the new units, it's quite common.
Yeah, I was asking because maybe you have a double check there with 2 thermowells.
Yeah, and one of the plants I was recently working with, they had 3 at the outlet of each pass and a combined. And fairly soon into the run, most of them were aligned to plus or minus a degree, but there was a couple that were just kind of like oddball outliers. And, everything was nominally clean, so we're kind of scratching our head as to what's true. But, we know this measurement can be unreliable.
Yeah, of course. Thank you.
Any other comments from the floor on that topic?
Hey, Evan, this is Robert with WICA again. Hey, when you talk about accuracy here, when we talk about thermocouples, we can make sure that thermocouple is accurate. And of course, on these wells, you can pull the thermocouple out and do a verification on it with a bath or a hot box or whatever. Remember, these are full systems, and so especially on the coil outlet, when you've got coke formation and other things going on with aging, you're looking at the accuracy of the system, and that's where these get to be really complicated answers. The thermocouple may be accurate, but the system as it changes and evolves, that's the tough part. And then even on redundant systems, they may have the same induced error being created just because of the system.
Yeah. I mean, the thermocouple itself is probably plus or minus 1/10 of a degree, right? I mean, they're super accurate.
Depends on the thermocouple, but we like to think they're as accurate as we can get them.
So let's move on to the next question. Do you use tube scan or thermal scan to initiate spalling? I'll give you my answer. Yes to both. Most of the time, when you get, you're monitoring it daily with the skins, and then as you get to the end of the run, you start doing the scans more frequently to dictate when you need to spall. That's my feedback. How about others? Not just the Evan show. I want to hear back from the audience.
Evan, this is Jack Buckley. Can you hear me?
Hi, Jack. Nice to hear from you, buddy.
Basically, we try to use both. You use the skin temperature indicators as a way to tell you when you really need to do a good thermal scan. But as you mentioned, doing a good thermal scan is an art rather than a science.
Very much agree. Very much agree. Any other comments? I know some of you have struggled with this. One of the topics I often ask in my training is, what is your true end of run temperature before you initiate spalling? And, there's a lot of discussion and debate around that. How deep into the end of run are you willing to get before you actually do the spalling? Means your spalling frequency goes up, but also gets easier. So there's some pros and cons there.
I just have a question. Is my mic working? I don't know.
Yeah, I can hear you.
Okay, this is Ellen Ozowski. I was wondering if when you say to do more thermal scans as your TMT temperatures increase, are you recommending, or is it industry standard to do thermal scans before every decoke?
I'd say not everyone does it. It depends on whether or not you have the in-house capability in your plant to do it. If you have an inspector in your plant that has the camera, more the better, right? Because you have that sunk cost. If you have to hire a third party to do it, which many sites do, obviously they're doing that less frequently.
Okay, thanks.
Good question. All right, I think next question is sort of building on the last one. How do you determine if the IR scan data, and I'm reading this for the benefit of our friends on the phone who don't have the screen access. How do you determine if the IR scan data or tube skin temperature is more accurate? We typically see a 50 to 100 degree Fahrenheit discrepancy between the two. So there's a lot to unpack there. As Jack alluded to, getting good infrared scans is very tricky. Like I said, I think we've had some people at the conference give presentations specifically about this, and I have some material too. But determining your emissivity and is one part of the puzzle to get a slightly more accurate number, but then also, you know, minimizing the distance you're trying to read across is also something that, if you have extra ports, helps you know, improve your accuracy. You know, if you're just going from the side port of the furnace through the flames to the tubes, which are 25 feet away, you can get pretty substantial differences in measurements. My personal preference is actually just to use the skin temperature IR data as directional information, not absolute temperature information. I like to see multiple scans. You know, when somebody calls me up and says, hey, I'm having a heater fouling problem, I said, all right, well, send me the last 5 IR scans you have, right? But I like to see them side by side with, and this is where it becomes the subtlety that Jack alluded to, is you got to have the same settings, you got to have, you know, the same color ranges on the output from the FLIR program, because you can be swayed in one way or the other if, you know, you're looking at, you know, this color pink or this color gray is different, you know, because the person who did the report set it up differently. You can have a dramatically different opinion about what happened. So, but I think you should be able to get to within, I would say 50 to 100 is quite high. I would think you could get into probably in the order of 20 to 30 degrees comparable. And, you know, some of the tricks that people will do is actually, you know, try to take a measurement as super accurately as possible right next to the skin temperature and kind of use that as the basis for comparison. That is fraught with some other issues, again. Yeah, you should be able to do better than that. If that really big temperature, I maybe suspect scale as something that's potentially giving you that much higher reading. Any other comments from the audience? Who does better than that? Who can get within 10 degrees Fahrenheit, 5 degrees C on your IR? Does anybody do it?
Hey, oh, sorry, go ahead.
Can you hear me?
Yes.
Yeah, Mitch Maloney here. Yeah, I just wanted, I'll comment just on the infrared stuff. I mean, it really helps to get an infrared after you've done an online pigging and you've got clean tubes. Hopefully you did a good pigging, and you know, that serves as a nice baseline that you can then compare as the tubes coke. So you don't have to be spot on accurate with the absolute readings, but you know, it's the differential that correlates to coke anyway. So that's something you want to consider doing. And a lot of sites, you know, have that insight capability. I think more and more the heater specialists can do infrared temperatures, and they're real skilled in the art. Just like Jack said, it's an art. So you got to orient things from the right place and do it consistently. There's a lot of stuff there. And I just wanted to go back to the COT thing real fast. I mean, the consideration is you got to stick the Thermowells into the pipe enough that they don't get covered up with coke and still read the process temperature. But you got to get a dispensation on vibration criteria often to do that. So, you know, as the thing cokes, it's going to stabilize the thermal well, and the calculations don't take any credit for coking around it and stabilizing vibrations. So you got to make some trade-off there. And then there's the whole spalling and erosion of the thermal well and how that plays into the orientation too. and putting cellulite coatings on and stuff like that. So those are all considerations. Anyway, I don't want to take more time.
Thanks, Mitch. Just by way of, for everyone's reference, two things that we're going to be covered in the coil outlet. Everything that Mitch said, he gave a presentation, I don't know, 5 years ago-ish maybe, at coking.com for this exact topic, and that presentation can be found in our past presentations on the website. Also in the forum, in preparation for this, there was a conversation between Maximiliano and Mike Kimbrell a couple of years ago about insertion length of thermocouples and for CO2 readings. And I was going to address that here, but because we jumped over to the skin temperatures, we'll do that another time. But there are references out on our website for past presentations and forum activities, and we've addressed some of these topics previously. But good comments, thank you, Mitch. I haven't been doing a good job monitoring the hand raising, so I want to do that here as we're sort of closing in on time. The gentleman Rupam Mukherjee, Rupan, you raised your hand a while ago, and I want to see if we can ask your question.
Yeah, hi. Am I audible?
Yeah, you're quiet though. Can you speak up?
Yeah, hi. Actually, my question is that we have a coca furnace where the highest temperature is read in the skin thermocouples in the top section of the radiant tubes. Although the burners are, there are skin thermocouple near the burners, but those are reading quite cooler temperatures. So I'm a bit perplexed, like what can be the possible reason where the top radiant tubes are reading higher temperature compared to the lower radiant tubes, which are more closer to the burners? Can you throw some light on it, please?
Yeah, I can, and I know some other people in the audience have struggled with this as well. So I'll give my 2 cents and then open it up to the floor. Basically, different contaminants in your feed can cause different types of feeds, and different contaminants can cause early fouling, sort of instability-related fouling, aggressive coking higher up in the radiant. So you have to look to your feed quality for this. That's on the process side, but then also on the flue gas side, if you're getting incomplete combustion and getting afterburn, we have also seen before some aggressive fouling in the upper radiant section because you're hotter up there than you would normally think you are. That's my 2 cents. Anyone else have something to add there?
Evan, this is Dale. Can you hear me?
Yes. Hi, Dale.
Oh, hi. I'm finally getting the technology working a little bit better. We've seen a little bit of middle to upper radiant fouling, and when we pigged it, we analyzed for metals, and in particular, we got silicon and molybdenum. And, not really understanding molybdenum at all, and silicon should only be going into the coke drum, not the furnace, unless the production facilities are using a lot of ANF foam or something like that. But so I'm just wondering about anybody if they've had experience with these or has done the kind of analysis and found maybe unexpected metals or unexpected contaminants there and knew where they were coming from.
Good point. Weird things in your feed can cause this problem. Any other comments? All right, well, we're just at the, go ahead.
One other comment, Evan, is if you're running, it really doesn't get up way high in the firebox, but if you're running higher excess oxygen, it can also raise where the highest temperature is in the firebox.
Agreed. Yep. Not just afterburn, pushing up with excess oxygen. Agreed. Good call.
Yeah. Hello.
Yes.
Yeah. So, like he said, we also have had some problems of our convection coils skin temperatures reading higher than the design temperature. So basically, the convection coils are the design temperature is around 450 degrees, and so I'm not sharing the details, but they are of the same material, that of the radiant tubes. So do you think we can push them up, and is it a problem if they read like 60-70 degrees higher than the design temperature, or is there something happening there?
Well, do you online Spall or do you pig?
Yeah, so basically we do a pigging in every 3 months, and we Spall whenever the temperature runs high.
Okay, well, one of the things you have to keep in mind, aside from the absolute temperature, is that Spalling doesn't do a very good job of shaking the coke free in the convection section. So, you know, you may get yourself in a position where, you know, it builds over time and you have to come back for a pig prematurely.
Okay, sir. And just another thing, do you think like in any way it would be related to something like an afterburn at the convection coil?
I believe, yeah, it's rare. I have seen it though. Does anyone else have any comments for this gentleman?
Convection section temperatures can also get high due to inorganics, salts, sodium, calcium, whatever, and they're hard to remove in online Spall.
But just coming back to that, I mean, I've seen that in every shutdown and startup that we take, it's not the same convection thermocouple reading high. It changes.
When you pig, can you get samples of the coke deposit separate from convection and radiant and analyze the coke?
Oh, we've not gone forward and done that, but I think it's high time we do, right?
Excellent question. Thank you. So we're just over our time slightly, so let's just do our wrap up briefly, and then we'll let you get on back with your day. So obviously there's some nuggets, and I wish we had a little bit more time to kind of get people's key takeaways. You know, a couple of ones that I wrote down. You know, infrared is a challenge for us. It's an art, but I really like Mitch's idea about getting a baseline infrared after a pigging. So that way you have that data as reference for determination of emissivity and kind of baseline scan information. So that one's great. I also, you know, Dale's comments about, you know, strange contaminants, silicon, molybdenum is something to keep in mind, and you know, it just came back in that second question there a minute ago. So I also want to just sort of recap the polls just briefly. So I'm going to drag my other screen over here. No, I apologize, it's small. There's no way for me to make this bigger. So in summary, most people have 5 to 10 thermocouples per pass. Most people are doing about 5-ish of replacing them during shutdowns, but some are doing none. Most people their skin TIs are built out of 310, but a lot don't really know. So I'd encourage you to go find out. Someone in your operation should know. The majority of people are sort of in the 1 to 3 Fahrenheit per day, which is what we would expect. And lastly, we wanted to find out what was the frequency that you guys prefer to have this forum. It seems like most of the people are voting for twice a month, and I got 27 respondents there. So we really do appreciate it. This is our first go around of this. We would desperately asking you to fill out a survey for us. I know we all get surveys for everything we do anymore these days, but this is our first time doing this. You know, we'd really appreciate the feedback, how to make it better for you. And, you know, in this time of COVID, you know, we're just trying to figure out ways to kind of keep the refining community together. So please complete the survey. We really do appreciate it. Our next one of these is slated for 2 weeks from now. That's the topic. The registration is open on the website, or you can use that fancy QR code again. We're going to be talking about coke dump steam stripping, a little bit less equipment focused, more process focused. So that's going to happen in 2 weeks' time. So without further ado, I really appreciate everybody logging on. Everyone was very good from an organizational perspective on the meeting. Technology worked, awesome. I hope it worked for everyone. And I really appreciate everybody getting on the horn with us today. It's been excellent. Thank you.
Thanks, Evan.
Thanks,
Cheers.
Evan.
Thank you.
Thanks, everyone. Thank you.
Thank you.
Bye.
Thank you.
Many
Thank
thanks.
you.
Bye-bye.
Bye-bye.
Thank you.
Thanks, Evan. See you in the next call.
Absolutely. Thanks, everybody. This has been fun. I'm just going to turn it off for everybody in the meeting.
Thank you. Good job.
Oh, thank you. Very kind.
Thanks a lot, man.
Evan, maybe 1 or 2 more minutes in case people still want to hit that poll, or, well, no, the poll is, that's okay. Slido is
Yeah.
separate.
Let me bring it up. Maybe the people have that. I'm going to put the poll into the chat window just in case. All right, seems like it's just trickling down. All right. I'm going to kill it. Everybody have a nice day. Wash your hands.
Bye, Demir.
Well,